Hi, this is question number 42 from chapter 6, section 2, and it deals with carbon dating. So it says that carbon 14 dating assumes that the carbon dioxide on Earth today has the same radioactive content as it did centuries ago. If this is true, the amount of carbon-14 absorbed by a tree that grew several centuries ago should be the same as the amount of carbon-14 absorbed by a tree growing today. A piece of ancient charcoal contains only 15% as much of the radioactive carbon as a piece of modern charcoal. How long ago, so you're trying to find the time, how long ago was a tree burned to make the ancient charcoal? And they give you the half-life, which is 5,715 years. 5,715. So, one of the things is they don't exactly give you how much carbon you began with, but they give you this percentage. So what you can assume is that, to make the math really easy, that you started off, and when you started off, your time, your number of years is 0, t equals 0. You had, let's say, y equals 100 grams, 100 100%. And instead of using percent, I'm just going to use the 100. So you start off with 100, and then t, your current time is, you don't know, so you're trying to find, and then you end up with 15%. So you know that when you're doing exponential growth, when you're doing carbon dating and stuff, you use the exponential growth and decay equation, which is y equals c, which is a constant, times e to the k, which is a constant, t. Okay, so when you're given t equals 0, do that part first. So what you would do, you'd plug in 100 equals c times e to the k times 0. And then k times 0 is 0, and e to the 0 is 1. So you're left with 100 equals c. Now that you know what c is, your modified equation is y equals 100 e to the k t. You still don't know what k is, but you're given the half-life of carbon right here, 5,715 years. So if you start off with 100%, and that if the half-life is 5,715, then 5,715 years later, you're going to be left with 15%. So you can just plug in 50%, sorry, not 15. 50 equals 100 e to the k times 5,715. So this comes out to be 50 divided by 100, that's 1/2, equals e to the k, I'm just going to say t for now because you know what the t is, and then you put this in natural log form, So that would be natural log of 1/2 equal to k times 5,175. Then k would equal negative 0.000134, and this is just like this, it's rounded up. Yeah, and that's k. So then you take this and you plug it into the final equation, and now that you know what the two constants are, you can solve for y equals 15%. So that would be 15 equals 100 e to the, this is supposed to be negative because, you know, half-life and it's decaying, to the, I'm just going to say k, it's a long number, and t, and you want to find t. So when you plug in this for k and you solve for t, you get t equals 14,163.8 years. Wow. Yeah, and that's it. That's the answer for question number 42.